So yeah, our next speaker is Brent West, who's Associate Director for Information Government and Strategic Initiatives at the University of Illinois. And he's going to share his workflow for AI-based email. I know you've got a snappier title than that, Brent. So if you're happy to start driving your PowerPoint presentation, I'll hand it over to you.
Sure. Thank you, Michael. Hopefully you can see my slides just fine.
Yep.
Great. Yeah, so I wanted to share a little bit about a project that we actually undertook, wrapped it up in early 2020, but we are starting another round of it. So our goal or our problem that we set out to solve was just the huge unorganized, unstructured data that is email, and that it's often scattered with sensitive content of various sorts, HR matters and financial information, internal company information. And that really presents a challenge that other structured, categorized, foldered, and form-based electronic records don't typically present as often. The issue that we were trying to see, or what we were trying to solve for, specifically why we're focusing on email, is the context that usually provides to our decision makers. Email is often our most requested public record in a Freedom of Information Act request, which gives a little bit of an indication that it seems like the general public has a lot of documentary and evidentiary value in email. And of course, the people who created it hold on to it for a very long time, typically. So they often found it very helpful as well. But the challenge we're trying to face is, what do we know, or how do we know what to keep? Capstone, the Capstone methodology that the U.S. National Archives developed helps identify accounts that are of interest, but within those accounts, we know there's going to be really non-archival content. And then within non-Capstone accounts, we know there are going to be some archival content. So our goal was really to try to figure out how we can identify the content which should be retained, and also what to do about personally identifiable information or other sensitive information that's in that data. We the result was that these records, if we don't do anything, the records will just end up getting ignored and deleted, or preserved and neglected. More often in our case, it was the former. The email of our administrators, our presidents and chancellors from the early 2000s, much of it was already gone. So trying to stem that loss had us looking at what can we do in this area. So we undertook this project, and actually this project that I'll talk about is primarily focused on the state of Illinois and its governmental archives, the email of governors, deputy governors, agency heads, and things like that. So we were trying to look at how we could prevent the loss of this asset, how we can raise awareness of its value, and also to prevent the risk of format obsolescence when these 20-year-old PST files contain all kinds of attachments. And we saw that we have solutions for acquiring email, the Capstone policy, the PST and inbox formats, reformatting, email and similar tools, indexing. Acrobat can easily OCR large batches of content, all kinds of solutions for preserving, arranging, and describing, and even accessing, such as EPAD or Preservica. But the unmet need that we saw was how to classify unstructured data sets at the discrete item level. And what we proposed to solve this was predictive coding, which is taking a statistical model and training coding sets of data for a training set to build the model and a control set to test the model, and use that to process a large collection to make decisions with relatively high confidence backed by a lot of great statistics. So the project in question here was, again, it's a National Historical Publications and Records Commission funded project that we completed with the Illinois State Archives. We started off with 5.3 million messages that were provided, and these again came from senior state officials dating back to the year 2000. There were 68 people, 415 PST files, 516 gigabytes worth of data. Some of them contained messages from, typically the governors didn't use email that much, but a lot of their general counsel, their deputy directors, chiefs of staff, a lot of content in there. And as you can imagine, some of it is sensitive. So our workflow that we built was to initially migrate the format from the original PST file that was provided to a more preservation-friendly EML format. That also helped us with creating a unique identifier for each individual email message. In a PST file, they're all just kind of lumped together, and there's not necessarily a unique ID. And the email committee tool also was able to do a deduplication. So that took us from that 5.3 million messages down to 3.6 million just by that deduplication. Then we imported into a tool. It's called Nuix Discovery now, but it was called Ringtail back then. And we use that to appraise and search for potentially sensitive content. Importing it into that tool extracted the attachments from the email, so we're back up to 4.7 million documents at this point. It also OCR'd any scanned images or other documents that didn't have any text associated with them. And then we began training this active machine learning model. And that model, with I believe it was about 5,300 documents that we coded, we were able to take that 4.7 million document collection down to 2.4 million of ones that we've identified as being archival, ones that should be retained. So it was about half of the email it was able to identify was something we traditionally wouldn't take in. We also did another round of training to try to find restricted data, sensitive data, and that one took a little bit longer. We coded more like 20,000 documents, and that identified about 500,000 documents that should be set aside for further review. After we were done with that, we moved the content into Preservica, and use that as our kind of our long-term storage and preservation environment. That also was able to do some format migrations on some of the older attachments. And then we moved on to access. We created an offline terminal in the reading room of the Illinois State Archives using ePad. We loaded up the content that was identified that was not restricted, which was about I think 1.5 million or so messages, and those were made available to the public in that reading room. This is what the tool looks like when you're coding the documents, and I'll just talk through this a little bit. On the left are different filters, and a lot of this is heavily customizable. You can add and rearrange the different panes. There's a lot more information here that I'm not showing, but the left side is a way to sort and organize the data, so you can quickly filter down to certain organizations, people, document types, whether or not the document's already been coded, different attributes, metadata about the documents. The next pane is a list of all the documents that I'm currently working with, and again, very customizable in which metadata fields you can see. Typically, you'd see like the document title or the subject line, the date of the document, which is typically the date of the email, or possibly the date it was created if it was an attachment. But you can have the to from, the email domain, all sorts of other columns that you can use to sort and organize. The next column over is a view of the particular message I've got highlighted, so you can actually read through it. There's a couple different views you can look at here. There's a like a more native viewer version, or you can look at like a plain text version. And then on the right is our coding panel, where we would actually decide. In this case, we decided this one was a non-archival document. and it had no restricted content. It was open to the public. A couple of other fields on that last pane were the flag for second review. If there were cases where you're kind of going through and coding, it takes probably about 100 documents per hour, as many we were able to code at a time. And you don't really want to get bogged down too much, really diving into a document, reading it heavily. If you are reading it at a quick glance and it's absolutely say non-archival, it's most of the time we were able to just tag them immediately with a decision and be fairly confident about it. But sometimes it was a very long or detailed document. Sometimes it was kind of an edge case where you could see it maybe being either way. And so we just provided a little checkbox to tick for people to move along and allow somebody else to come back and kind of put a second set of eyes on those. We also provided a place for comments, and at one point we were tagging specific issues if this was an issue related to a certain piece of public policy, and there was some interest in that. We were tagging those in the issues field. But primarily it was just read the document and code the archival or restrictedness of it. The model would then learn from all this coding that you've done on the training set and build some sort of an algorithm. And we decided we wanted to make sure, especially in the case of archival content, that we were keeping as much as possible. So we set our recall at 95%. That is, everything that is archival, we want at least to make sure that we're keeping 95% of it. It's not 100%. The only way to keep 100% would be to review every single document one by one, and even human coders are fallible. So we knew you're never going to get perfect. 95% seems like a really good goal, though. And then we focused on this accuracy number, the green line here. And we were trying to get as high of an accuracy as possible while holding that recall fixed. That allowed us to basically say we're keeping all the archival stuff, that the amount of archival content is fixed. We're always going to keep that much of it. Now what we're focusing on is getting rid of the non-archival content. So as we get better trained models, that performance improves to the point where it's identifying what makes a document non-archival, and so we can let go of it. There's some statistics in the background here. These are based on a smaller subset, so it's not the full, the numbers aren't full, but the percentages are still accurate. And you can see this kind of lighter gray peak that goes up to around -0.1 and then comes back down. That's showing the distribution of the documents based on a score that the algorithm has assigned each document. And it does this, it evaluates this using a control group. So we set aside a batch of documents, we've coded them. They're not used to train the algorithm. They're only used to score the algorithm to determine how well it's performing. And so it's a random sample, and using lots of statistics, it can fairly confidently give us some performance measures. So right now, with a fairly early on in the model, you can see a lot of the documents are right in the center, which means it's not confident whether it's non-archival or archival on the right side. And so that's what we're trying to do, is build up the model's confidence. So after several rounds of training and coding documents, this is where we finally ended up, where we got to just a little over 80% accuracy, and we felt pretty good about that. And you can see that peak is now shifted over, so a big portion of the documents are now beyond this -0.257 threshold that we've chosen. And so all the documents on the left in that peak area would be marked as non-archival, and all the ones on the right would be kept as archival. Again, we're keeping 95% of what we want to, and so we may be keeping a little bit of non-archival content, but that's the trade-off of just not having to code increasingly large sets of training documents. So the lessons we learned from this process was that this is very much an augmented process, not an automated appraisal. I don't think we're at the point, even with ChatGPT type technologies, that you could just throw all this content at an AI and let it make the decisions for you. The archivists very much still need to be involved. We found a huge labor savings. We only reviewed 26,000 documents out of 4.7 million. And so we were able to make higher quality content more readily accessible more quickly. So we were very pleased with that. We found that the capstone model does not mean that everything in it is archival. About 41% of the documents were actually archival out of documents, out of capstone accounts. So again, governors, deputy governors, high level people in the organization. Only 40% really warranted long-term retention. We also thought that this process may be useful with responses to public records requests. The sensitive information, personally identifiable information, is small, but it is important to be mindful of it. So it's less than 2% of the collection. We found in order to prevent that content from being released, we had to withhold 500,000 documents, even though only about 42,000 of them in our collection were actually sensitive. And again, that's kind of erring on the side of caution. We did find that the tool is great at using statistics to give you really quantifiable metrics and reducing the risk. So we knew exactly how many, well, not exactly, but a pretty good range of how many documents that we missed that would have been archival, how many we missed that would have been sensitive. And you just know what that trade-off is. I know that there's about 2,100 documents that are sensitive that we're going to miss, but we're going to find 40,000 of them, and we're going to withhold access to about 500,000 documents that aren't sensitive. But that's, again, that trade-off. That unless you read every single one of them, you're never going to get perfection. It is a bit of a black box in terms of a commercial solution. We don't really know exactly how the model works, what secret sauce they have that does this. We are just trusting, relying upon those statistics, that control group, to assess its performance. But we also thought, the human appraisal decision is also a bit of a black box. We don't really know how a human comes to their decisions, and you can train a human on how to code documents, but there's always going to be a lot of subjectivity involved. The tool is very forgiving to mistakes. You code enough documents, a few poor coding decisions due to fatigue or not understanding the material can be overcome, and the software has ways to identify those. There are trade-offs between privacy and transparency. Sometimes personal correspondence ends up in there, and sometimes that's useful context. Sometimes there's a restricted sensitive content in a document that's also, or maybe it's that personal content that's mixed in with work business. And do we restrict the entire document? Do we redact it? These are still some challenging issues. It is great. It's good to keep in mind that you should proceed deliberately and document everything. So we decided to keep our manual coding, even of the non-archival documents. We'll keep those documents so that we can reproduce it in the future. We also wanted to keep our the headers for all documents, even the non-archival ones, so we could do some network analysis, who's sending what to whom. It also provided a nice little index summary of the content that was purged without risking too much of it, since it's just essentially the to, from, and subject line. And we kept both the message and its attachment if either one of them was archival. And then the final lesson learned was to make this part of an overall life cycle: acquisition, reformatting, indexing, coding, classifying, preserving or purging, arranging, describing, accessing, reappraising. And I just thought I'd throw out there also this, the current case we're working on right now is about 216 gigabytes worth of PSTs, 139 gigabytes is what was brought into Ringtail after it was deduplicated, and we were able to reduce that by about 50% through this process. So cut the content in about a third, essentially. And it takes a cost of about $1,100 a month for this tool. So that's the other caveat, is using a commercial tool best of breed like this is fairly expensive. So I have a few other slides that I'm happy to share after the fact, but I know we are getting close on time. But that just walks through more screens of the tool, the process of the ingestion, the results of the ingestion, and the types of metadata it collects, some description, kind of a word cloud of this particular data set, some ways to drill into the data based on dates and types of documents, some network analysis, and another example of how we were looking at redacting by word frequency. So I'll stop there.
No, thanks very much, Brent, and thank you for keeping an eye on the clock. Saved me a job. I see we've had a couple of questions come into the chat that you might just have time to pick up. So the first one came in, and I think you might have touched on this actually, was Christopher Werner, who said, did you find the documented policies clearly defined, what was archival and restricted, etc.? Or did you have to set your own subset of policies to code the AI?
It was definitely there were no documented policies. We worked with the director of the Illinois State Archives and first had a conversation about, what kind of material we should be looking for. And we actually even sat down with him and several of his team to code together all in the same space so that we could, in those early conversations and early decisions, sort of come to a similar mind in terms of what should be kept. But it is not a process, speaking with them and our own University of Illinois archivist, it is not something that comes natively to archives to go down to like the individual discrete document level. You're usually assessing at a more folder or box level. So it's a challenge definitely to get everybody on the same page.
Thanks, Brent. And then there's a question here from Ellen, who says, had you already worked on creating a model before? It sounds like you used the foundation model. Is that correct? And if so, she missed the name, so could you repeat it if possible?
So the first round of doing this was, we finished that up in 2020. And we did have the idea, because that was a 500 gigabyte set of data, we had the idea of let's start with a smaller subset of it, code that, and make sure we understand how this works. And then we expanded to the remainder of that data set. We thought, since we've already coded a model from that first batch, let's see if we could apply that to this remainder of the batch. So like say 10% of it and then 90%. It was not as successful as we thought. We thought we could take this pre-built model that's already has 2,000 documents coded and apply that to this larger model. And even though it was some of the same custodians, the same account owners of the email accounts, surprisingly, the model took just as much training, it seemed like, as if we had just started from scratch. So we just began another round 3 months ago, and because this is University of Illinois data instead of the state of Illinois data, we started over from scratch. I don't know if there are techniques that we could find eventually that would allow reuse of those models, because that is something that does seem like it should work, but so far we haven't had a lot of success with that.
Okay. All right. Well, thanks for that, Brent.